Welcome. Today we will determine the domain and range of four functions involving trigonometric expressions. We will sketch the graph of each function to visualize its domain and range. The four functions are f of x equals x times sine of x, f of x equals x times sine of 1 over x, f of x equals 1 over 8 multiplied by x squared times sine of x, and f of x equals sine of x divided by x. Recall that the domain is the set of all input values, usually x values, for which the function is defined, and the range is the set of all possible output values, usually y values, that the function can present as the input varies over its domain. Let us begin. The yellow curve shows f of x equals x times sine of x. This function is the product of two functions, x and sine of x. The function x is defined for all real numbers. The sine function is also defined for all real numbers. Since both factors are defined everywhere, their product x times sine of x is also defined for all real numbers. There are no denominators that could be 0, and no square roots requiring non-negative inputs. Therefore the domain is all real numbers, written as the open interval from negative infinity to positive infinity. For f of x equals x times sine of x. Since the sine function lies between -1 and 1, the product x times sine of x lies between minus the absolute value of x and the absolute value of x. The graph oscillates between the lines y equals x and y equals minus x. As x grows in magnitude, the oscillations grow without bound. The function takes all real values. Therefore the range is all real numbers. The open interval from negative infinity to positive infinity. The blue curve shows f of x equals x times sine of 1 over x. The expression 1 over x requires x to be non-zero, because division by 0 is undefined. The sine function is defined for all real numbers. So sine of 1 over x is defined for all x not equal to 0. Therefore the domain is all real numbers except x equals 0. Domain equals the union of the open interval from negative infinity to 0 and the open interval from 0 to positive infinity. For f of x equals x times sine of 1 over x. Please see the details description of range of this function at the end of this video. The value of this function never actually reached to 1. And this function also has a global minimum of approximately -0.217. Therefore the range is from -0.217 to 1, including -0.217 but not including 1. Range equals the interval from -0.217 to 1. Closed on the left and open on the right. The green curve shows f of x equals 1 over 8 multiplied by x squared times sine of x. This function is the product of 1 over 8 times x squared and sine of x. Both 1 over 8 times x squared and sine of x are defined for all real numbers. There are no restrictions of any kind. Therefore the domain is all real numbers. The open interval from negative infinity to positive infinity. For f of x equals 1 over 8 times x squared times sine of x. 1 over 8 times x squared is always non-negative and sine oscillates between -1 and 1. So 1 over 8 times x squared times sine of x lies between minus 1 over 8 times x squared and 1 over 8 times x squared. The graph oscillates between the parabolas y equals 1 over 8 times x squared and y equals minus 1 over 8 times x squared. As x grows, the amplitude grows without bound in both directions. The function takes all real values. Therefore, the range is all real numbers. The orange curve shows f of x equals sine of x divided by x. The denominator is x, which equals 0 when x equals 0. Division by 0 is undefined, so x equals 0 must be excluded. The sine function is defined for all real numbers. Therefore, the domain is all real numbers except x equals 0. Domain equals the union of the open interval from negative infinity to 0 and the open interval from 0 to positive infinity. For f of x equals sine of x divided by x, when limit x tends to 0, sine of x divided by x approaches 1. If we expand sine of x into series of x and putting x equals to 0 after dividing by x, we get the limiting value 1. However, x equals 0 is excluded from the domain, so the value 1 is never actually reached. As x approaches positive or negative infinity, sine of x divided by x approaches 0. Because the bounded numerator is divided by a growing denominator, the global minimum of the sinc function occurs at x approximately equal to 4.4934, where sine of x divided by x is approximately minus 0.2172. This will be illustrated in another video. Therefore, the range is from minus 0.2172 to 1, closed on the left and open on the right. Range equals the open-closed interval from minus 0.2172 to 1. It will be illustrated in explanation part. Now let us compare all four functions together on the same graph. Observation 1. Domain. f of x equals x times sine of x has domain all real numbers, because both x and sine of x are defined everywhere. F of x equals x times sine of 1 over x has domain all real numbers except x equals 0. Because the expression 1 over x is undefined at x equals 0. F of x equals 1 over 8 times x squared times sine of x has domain all real numbers, because both 1 by 8 multiplied by x squared and sine of x are defined everywhere. F of x equals sine of x divided by x has domain all real numbers except x equals 0. Because the denominator x equals 0 is not allowed. Observation 2. Range. All four functions have not same. Though f of x equals x times sine of x and 1 over 8 times x squared times sine of x have range equal to all real numbers, because these two functions are unbounded and oscillates through all values. X is in denominator effects on range for other two functions, but these were same. In conclusion, for products of trigonometric functions, always check whether any argument or denominator introduces a restriction on the domain and range. Thanks and welcome to explanation part. Now let us first look at the helper function g of x equals sine of 1 over x. This function oscillates infinitely many times as x approaches 0 from either side. When x is large, 1 over x is close to 0. And sine of a small number is close to 0. So the function stays close to 0 for large x. As x gets closer and closer to 0, the argument 1 over x grows without bound, and the sine function oscillates faster and faster between -1 and +1. This rapid oscillation near x equals 0 is the key feature of this function. Notice that the graph never settles at 0 near the origin, it keeps oscillating infinitely. The domain of sine of 1 over x is all real numbers except x equals 0. Because 1 over x is undefined at x equals 0. The range of sine of 1 over x is the closed interval from -1 to +1. Because the sine function always lies between -1 and 1. Now we multiply by x to get f of x equals x times sine of 1 over x. We use the substitution t equals 1 over x. Then x times sine of 1 over x equals sine of t divided by t. This is the sinc function. Step 1. Finding the supremum. As x approaches positive or negative infinity, t equals 1 over x approaches 0. By the standard limit, sine of t divided by t approaches 1 as t approaches 0. However, t equals 0 corresponds to x equals infinity, which is never reached. So the value 1 is the supremum but is never attained. Step 2. Finding the minimum. We differentiate sine of t divided by t and set it equal to 0. This gives t cosine t minus sine t equals 0. Or equivalently tan t equals t. The first non-zero positive solution is t approximately equal to 4.4934. Step 3. Computing the minimum value. Substituting t approximately 4.4934 into sine t divided by t gives approximately minus 0.2172. This corresponds to x approximately equal to 0.2225, which is the minimum value of the function. Step 4. By continuity and the intermediate value theorem. Every value between minus 0.2172 and 1 is achieved. Therefore the range equals the half-open interval from minus 0.2172 to 1. Closed on the left and open on the right. Thanks for your patience.